At 0600 hours on June 14, 1942, an entry was made in the daily operational log of work number 417. The record noted nominal electrical frequency at 50.02 Hz, voltage stability within prescribed tolerance, and uninterrupted steam pressure at both turbine intakes. The morning shift commenced with full staffing, and attendance sheets were filed with the personnel office by 0615 hours. Coal reserves were measured at 1,420 metric tons, sufficient for continuous boiler operation under standard load conditions. No deviations were entered in the overnight security report submitted by the Works Protection Unit. At 0630 hours, the control room supervisor countersigned the previous shift's entries and authorized initiation of the scheduled load increase sequence. Switchgear indicators confirmed circuit readiness, and maintenance teams reported completion of pre-test inspections, including verification of lubrication levels and cooling flow rates. Instrument calibration certificates dated within the preceding 30 days were attached to the test documentation. By 0715 hours, load demand increased in accordance with the approved schedule. Transformer temperatures remained within acceptable limits, and no alarms were triggered on the primary distribution boards. Steam output from the boiler house was adjusted incrementally, with fuel feed rates logged at 5-minute intervals. At 0800 hours, confirmation of test authorization was transmitted to the control room by the administrative office and placed in the central file registry. At 0830 hours, the operational log recorded the facility approaching the designated test threshold. No corrective actions were entered. In the winter of 1942, within the administrative boundaries of the German Reich and under the jurisdiction of the Reich Ministry of Armaments and War Production, an industrial complex designated as Work Number 417 was operating under conditions of heightened security and accelerated output requirements. The facility was located in a secondary industrial zone connected by a spur line to a main railway artery serving the central manufacturing districts. Its primary function was the production of precision components for heavy armored vehicles, including gear assemblies, drive shafts, and hardened steel housings manufactured to specifications issued by the Army Weapons Office. The plant operated continuously in 3 shifts, with a workforce composed of German technical staff, conscripted civilian labor, and a contingent of foreign forced laborers housed in a guarded accommodation sector adjacent to the perimeter. The plant's administrative structure followed standard wartime protocols. Overall authority rested with a civilian plant director appointed by the ministry, while technical oversight was divided among department heads responsible for metallurgy, machining, power systems, and logistics. Security was overseen by an internal works protection unit supplemented by periodic inspections conducted by regional offices of the Security Police and the Armaments Inspectorate. Access to technical documentation, control rooms, and power infrastructure required written authorizations stamped with current security codes updated on a monthly basis. On January 14, 1942, the Personnel Office registered the arrival of an additional technical specialist assigned to the Power Systems Department. The individual was documented as a German national, holder of an engineering degree from a technical university in the Ruhr region, and previously employed in industrial modernization projects in occupied territories. His assignment orders bore the seal of the Reich Ministry of Armaments and included a directive authorizing unrestricted access to power distribution facilities for the purpose of efficiency assessment and output stabilization. The documentation was processed through the plant's administrative channels without delay, as the plant had received prior notification of an external audit team tasked with addressing recurring power fluctuations that had caused intermittent production stoppages during December. The engineer was assigned quarters in the administrative housing block reserved for senior technical staff. He was issued an internal access badge corresponding to Level 3 clearance, permitting entry to the main power hall, transformer yard, turbine annex, and emergency generator rooms. His name was entered into the duty rosters of the Power Systems Department, and his presence was noted in the daily operational log maintained by the shift supervisors. During the first 2 weeks following his arrival, the engineer conducted a comprehensive review of the facility's power infrastructure. This review proceeded according to established industrial protocols. He examined schematics of the primary electrical intake lines, transformer capacities, load distribution maps, and emergency redundancy arrangements. He requested archived maintenance records dating back 18 months, including reports of prior overload incidents, insulation failures, and repairs to turbine couplings. These requests were processed through routine channels and complied with by clerical staff accustomed to periodic inspections. The facility derived its primary electrical supply from a regional grid connection supplemented by an on-site power plant consisting of 2 steam turbines driven by coal-fired boilers. The turbines fed a central switchgear assembly that distributed power to machining halls, heat treatment furnaces, lighting circuits, and administrative systems. Emergency power was provided by 3 diesel generators installed in a reinforced annex, designed to sustain critical operations for limited periods during grid outages. Fuel storage for these generators was maintained in underground tanks connected by gravity-fed lines equipped with manual and automatic shut-off valves. Throughout January and February, the engineer was observed moving methodically between departments, accompanied at times by junior technicians assigned to assist with measurements and inspections. He recorded voltage fluctuations at different load levels, noted temperature variances in transformer oil, and reviewed the calibration of protective relays. His written reports, submitted weekly to the plant director and copied to the Armaments Inspectorate, identified no immediate deficiencies requiring shutdown but recommended minor adjustments to load balancing and scheduled maintenance intervals. On March 3, 1942, following a routine inspection by a regional security officer, the plant received confirmation that the engineer's credentials remained valid and that his assignment was to continue for an indefinite period. The confirmation referenced the ongoing need to ensure uninterrupted production amid increasing demand. No anomalies were noted in the inspection report. Beginning in mid-March, the engineer initiated a series of procedural changes framed as preventive maintenance measures. He recommended staggered testing of emergency generators during off-peak hours to verify readiness. These tests were conducted under his supervision and involved running each generator independently for specified durations while monitoring output stability and fuel consumption. Test results were recorded in the maintenance logs, which indicated normal performance parameters. During these tests, adjustments were made to the automatic transfer switches that controlled the transition between grid power and on-site generation. The engineer authorized recalibration of the switches to reduce transition time, citing the risk of damage to precision machining equipment during prolonged power interruptions. The recalibration was approved by the department head and implemented by maintenance crews under standard operating procedures. In parallel, the engineer reviewed the fire suppression systems within the power infrastructure areas. The facility employed a combination of water-based sprinklers and carbon dioxide extinguishing systems in enclosed spaces housing electrical equipment. Maintenance records showed that CO2 cylinders had been refilled and pressure tested in late 1941. The engineer ordered an additional inspection to verify valve responsiveness and distribution nozzle alignment. These inspections were carried out without incident, and no deficiencies were recorded. Throughout April 1942, the engineer's role expanded to include coordination with external suppliers delivering replacement components for turbines and switchgear. He reviewed shipment manifests, verified specifications, and authorized storage of spare parts in designated secure areas. His access to these storage areas was consistent with his clearance level, and his presence during inventory checks was documented. On April 22, 1942, a scheduled maintenance shutdown of one steam turbine was conducted to replace worn bearings. The operation followed a detailed procedure: gradual load reduction, isolation of the turbine from the grid, controlled cooling, disassembly, replacement of components, reassembly, and testing. The engineer was present throughout the process, observing measurements and signing off on completion forms. The turbine was returned to service after 48 hours, and production resumed without reported issues. Following the maintenance operation, the engineer submitted a memorandum recommending an increase in operating pressure for the boilers supplying the turbines, within permissible safety margins, to improve efficiency. The memorandum included calculations and references to technical guidelines issued by the ministry. The recommendation was approved after review by the plant's senior engineer and implemented gradually over the course of several days. In early May, the engineer requested access to the underground fuel storage tank serving the emergency generators. He cited the need to verify fuel quality and sediment accumulation, noting that extended storage could compromise generator reliability. The inspection was conducted with the assistance of a maintenance foreman and involved opening access hatches, sampling fuel, and checking valve integrity. The inspection report indicated acceptable fuel quality and recommended no immediate action beyond routine filtration. On May 9, 1942, a minor electrical fault occurred in one of the secondary distribution panels serving a machining hall. The fault triggered a protective shutdown of the affected circuit but did not disrupt overall production. The engineer reviewed the incident report and recommended replacement of a set of fuses with higher tolerance units to prevent nuisance trips. The replacement was approved and carried out the same day. Throughout this period, the engineer maintained a regular presence in administrative offices, reviewing correspondence from the ministry and submitting updates. His reports were formal, technical, and aligned with prevailing bureaucratic language. No discrepancies were noted by clerical staff or supervisors. By late May 1942, the facility's output had increased measurably, and the plant director noted improved stability in power supply metrics. These improvements were attributed in internal reports to the implemented adjustments and enhanced maintenance oversight. On June 2, 1942, the engineer initiated preparations for a comprehensive load stress test intended to simulate peak demand conditions. The stated objective was to identify latent vulnerabilities before the anticipated increase in production quotas scheduled for the summer. The test plan outlined a phased increase in load across all major circuits, coordinated operation of both steam turbines at near maximum capacity, and readiness of emergency generators to assume load in the event of grid instability. The plan was reviewed and approved by the plant's technical committee. Preparatory steps included verification of communication lines between control rooms, confirmation of staffing levels for the test period, and scheduling the test during a window of minimal external demand to reduce risk to the regional grid. Notices were circulated internally, and relevant departments were instructed to be on standby. On June 14, 1942, the stress test commenced at 0600 hours. Load was increased incrementally according to the approved schedule. Instrument readings were recorded at each stage, and no immediate anomalies were observed. At 0930 hours, the facility reached the targeted peak load. Both turbines operated within expected parameters, and voltage levels remained stable. At 1015 hours, the engineer authorized a simulated grid interruption to test the automatic transfer to emergency power. The grid connection was isolated, and the transfer switches engaged, bringing the diesel generators online. The transition occurred within the reduced time parameters established during earlier recalibrations. Critical systems remained powered, and no production equipment was damaged. The generators were operated under load for 45 minutes, after which the grid connection was restored and normal operations resumed. The test was documented as successful in the operational log. Following the stress test, the engineer recommended a brief shutdown of the emergency generators to conduct post-operation inspections. These inspections were scheduled for the following day and approved. On June 15, 1942, inspection of the generators revealed no apparent mechanical issues. Oil levels, temperatures, and exhaust readings were within normal ranges. The engineer signed off on the inspection forms and returned them to the maintenance office. In the days that followed, routine operations continued without incident. The engineer maintained his usual schedule, alternating between on-site inspections and administrative duties. His presence was noted in daily logs up to June 28, 1942. On June 29, 1942, an administrative directive was received from the Reich Ministry of Armaments authorizing a temporary reduction in security inspections for certain technical personnel to expedite ongoing efficiency measures. The directive referenced the need to minimize disruptions during a critical production phase. The engineer was included in the list of personnel affected by this directive, and security procedures were adjusted accordingly. On July 2, 1942, maintenance crews began routine cleaning of the turbine annex. The engineer authorized the temporary removal of certain protective covers to facilitate access. This authorization was recorded in the maintenance log. On July 4, 1942, at 2,140 hours, during the evening shift, an unexpected pressure increase was recorded in one of the boilers supplying the turbines. Operators initiated standard corrective actions, including reduction of fuel input and venting of excess steam. The pressure stabilized after several minutes, and no damage was reported. The incident was logged and scheduled for review. On July 5, 1942, the engineer reviewed the incident report and recommended adjustment of pressure relief valve settings to ensure more responsive regulation. The recommendation was approved and implemented under supervision. On July 7, 1942, the plant director issued an internal memo acknowledging continued stable operations and authorizing preparation for increased production quotas effective August 1, 1942. The engineer's last recorded entry in the daily operational log occurred on July 10, 1942, noting completion of routine inspections and submission of a summary report to the ministry. Subsequent administrative records indicate that his access credentials remained active and that no changes to his assignment status were recorded at that time. Following the administrative directive of June 29, 1942 authorizing a temporary reduction in security inspections for designated technical personnel, routine operations at work number 417 continued under established protocols. The adjustment did not eliminate existing procedures but modified the frequency of credential verification at internal checkpoints for personnel listed in the directive. Security logs from June 30 through early July reflect continued monitoring of entry and exit times, with annotations indicating compliance with the revised inspection schedule. During this period, the Power Systems Department maintained its standard reporting cycle. Daily operational summaries were compiled by shift supervisors and submitted to the department head at the conclusion of each shift. These summaries included recorded load averages, peak demand intervals, maintenance activities performed, and any deviations from nominal operating parameters. Copies of the summaries were archived in the department's records office and made available for review during inspections. On June 30, 1942, a scheduled inventory of spare electrical components was conducted in the secure storage area adjacent to the switchgear hall. The inventory process involved physical verification of transformer oil reserves, replacement fuses, relay assemblies, and cabling materials. The engineer was present for portions of the inventory and countersigned the verification forms confirming quantities and storage conditions. No discrepancies were noted in the inventory report. Coal deliveries to the boiler house during this interval followed the established timetable of 3 shipments per week. Delivery manifests were checked against purchase orders issued by the procurement office, and quality inspections were performed by boiler house personnel. Moisture content and calorific value samples were recorded in the fuel quality log. The engineer reviewed these logs periodically, noting consistency with contractual specifications. On July 1, 1942, the maintenance department completed a routine lubrication cycle for turbine bearings and auxiliary pumps. The procedure involved draining and replacing lubricants, inspecting seals, and verifying flow rates. The work was carried out during a low-load window to avoid production disruption. Completion was documented in the maintenance ledger, with signatures from the responsible technicians and supervisory staff. Throughout the first days of July, the engineer conducted periodic walkthroughs of the machining halls and heat treatment areas to observe power consumption patterns under varying production loads. These observations were recorded in handwritten notes later incorporated into formal reports. The reports focused on alignment between scheduled production activities and power distribution plans, with attention to avoiding simultaneous startup of high-demand equipment. On July 2, 1942, following authorization for cleaning operations in the turbine annex, maintenance crews removed accumulated dust and debris from structural surfaces, cable trays, and ventilation ducts. The work was performed using non-conductive tools and followed fire safety guidelines. The engineer authorized the temporary deactivation of selected circuits to facilitate safe access, and reactivation was documented upon completion of cleaning. Administrative correspondence during this period included routine exchanges between the plant director's office and the Reich Ministry of Armaments concerning production statistics and resource allocation. Weekly output figures were compiled by the production office and transmitted via secure channels. Power consumption data was included as a supplementary annex, prepared by the Power Systems Department and reviewed by the engineer prior to submission. On July 3, 1942, the facility underwent a routine internal audit of documentation practices. Clerical staff reviewed filing procedures, ensuring that maintenance records, inspection reports, and correspondence were properly indexed and stored. The audit report noted satisfactory compliance with record-keeping standards and recommended no corrective actions. The evening of July 4, 1942 saw the recorded boiler pressure increase that was subsequently addressed through standard corrective measures. In the aftermath of the incident, additional monitoring intervals were instituted on a temporary basis. Pressure readings were logged at shorter intervals, and supervisory staff were instructed to report any deviations immediately. The engineer reviewed these enhanced logs on the 5th and the 6th of July, confirming stabilization following valve adjustments. On July 6, 1942, a scheduled delivery of replacement instrumentation arrived, including pressure gauges and thermocouples intended for installation during upcoming maintenance windows. The procurement office logged the delivery, and the items were stored under controlled conditions. The engineer inspected the shipment and verified conformity with specifications before authorizing acceptance into inventory. Training and briefing sessions for technical staff continued during this period. Shift supervisors conducted briefings at the start of each shift, reviewing safety protocols, current operational priorities, and any procedural updates. Attendance was recorded, and briefing summaries were filed. The engineer attended selected sessions related to power system operations, providing technical clarifications as required. On July 7, 1942, the plant's Internal Works Protection Unit conducted a routine perimeter inspection. The inspection covered fencing, access gates, lighting, and alarm systems. Findings were recorded in the security log, which indicated all elements were functioning as intended. The reduced inspection directive did not affect perimeter security measures. Throughout the 8th and the 9th of July 1942, maintenance crews performed minor adjustments to ventilation systems in the power infrastructure areas to improve airflow and temperature regulation. The adjustments involved recalibrating dampers and cleaning intake filters. These actions were documented as preventive maintenance and approved through standard channels. On July 9, 1942, the engineer compiled a mid-month summary report covering power system performance, maintenance activities, and compliance with efficiency directives. The report included tabulated data, references to prior inspections, and confirmation that operations remained within prescribed parameters. The report was submitted to the plant director and forwarded to the ministry as part of routine reporting. The final routine inspection conducted by the engineer during this interval took place on July 10, 1942, focusing on verification of documentation completeness and confirmation that all scheduled maintenance tasks had been executed. The inspection checklist was completed and filed. No outstanding issues were recorded. Administrative records for this period conclude with the entry noting the engineer's continued assignment and active credentials, with no amendments or annotations indicating changes to operational status. On July 11, 1942, the morning shift commenced under standard operating conditions. Personnel attendance records indicated full staffing across production, maintenance, and administrative departments. Power supply metrics recorded at 0600 hours showed nominal voltage and frequency stability across all primary circuits. Coal deliveries to the boiler house were logged at 0545 hours, consistent with the established supply schedule, and fuel reserves for the steam turbines were assessed as sufficient for continuous operation through the week. At 0830 hours, the engineer submitted a written request to the plant director for authorization to conduct an unscheduled verification of emergency power readiness. The request cited the upcoming increase in production quotas and referenced recent minor pressure irregularities as justification for additional checks. The authorization was granted the same morning, consistent with the directive allowing reduced procedural delays for technical personnel engaged in efficiency measures. The maintenance department was instructed to provide assistance as required. Between 09:30 and 1200 hours, the engineer was present in the emergency generator annex. Maintenance logs record that access doors were opened, ventilation louvers adjusted, and diagnostic instruments connected to generator control panels. No irregularities were noted in the logs, which document routine readings of oil pressure, coolant temperature, and fuel flow. The engineer signed off on the interim checklist at 1,205 hours. At 1,330 hours, the engineer proceeded to the central switchgear hall. Security records show his access badge was scanned at the main entry point, and his presence was noted by the control room supervisor. He requested the latest load distribution charts and reviewed them alongside the supervisor, focusing on the allocation of power to heat treatment furnaces and high torque machining lines scheduled for extended operation in the coming weeks. The review was completed without recorded objections or amendments. On July 12, 1942, the engineer submitted a memorandum proposing a reconfiguration of certain secondary distribution circuits to optimize load flow during peak periods. The memorandum included technical diagrams and referenced established electrical engineering standards. Approval was granted by the Senior Technical Committee, and implementation was scheduled for the following week, to be carried out incrementally to avoid production disruptions. From 13 to July 17, 1942, the engineer oversaw the initial phase of the reconfiguration. Maintenance crews rerouted selected circuits through alternate bus bars, installed additional monitoring points, and verified insulation integrity. Each completed step was documented in the maintenance records, which indicate compliance with safety protocols and absence of incidents. Production reports for this period show no significant interruptions attributable to the reconfiguration work. On July 18, 1942, a scheduled inspection by the Regional Armaments Inspectorate took place. Inspectors reviewed production output, maintenance records, and compliance with efficiency directives. The Power Systems Department received a satisfactory assessment, noting improved stability and preparedness for increased demand. The engineer was present during portions of the inspection and provided technical documentation upon request. No adverse findings were recorded. In the final week of July, preparatory measures for the August quota increase intensified. The boiler house increased coal intake, and maintenance schedules were adjusted to ensure maximum equipment availability. The engineer participated in planning meetings focused on sustaining continuous operations under higher loads. Meeting minutes reflect his recommendations regarding staggered startup of heavy machinery and prioritization of critical circuits during peak periods. On July 30, 1942, a routine test of the fire suppression systems in the power infrastructure areas was conducted. Water-based sprinklers were tested sequentially, and CO2 systems underwent pressure verification without discharge. The engineer observed the tests and confirmed compliance with safety requirements. Test results were filed in the safety office. At 2,200 hours on July 31, 1942, the plant transitioned to the new production schedule. Power demand increased as anticipated, and initial readings indicated stable performance. Night shift logs report no anomalies during the first hours of augmented operation. On August 1, 1942, at 0415 hours, a brief voltage fluctuation was recorded on one secondary circuit. The fluctuation did not trigger protective shutdowns and resolved within seconds. The incident was logged and reviewed by the engineer later that morning. He noted the event and recommended continued observation without immediate intervention. Throughout the first week of August, the facility operated under sustained high-load conditions. Daily reports documented consistent output and acceptable power system performance. The engineer continued his routine inspections and administrative duties, submitting periodic updates to the ministry. On August 8, 1942, the engineer requested authorization to conduct a full-scale test of the emergency power system under maximum load conditions, citing the prolonged high-demand operation and the need to validate contingency readiness. The request was approved with the stipulation that the test be coordinated to minimize production impact. A test window was scheduled for August 12 during a planned reduction in non-essential machining operations. Preparations for the test included verification of fuel reserves, inspection of transfer switches, and notification of relevant departments. The engineer oversaw these preparations, and completion was documented in the operational logs. On August 12, 1942, at 0700 hours, the emergency power test commenced. Non-essential loads were isolated, and critical systems were prepared for transfer. At 0730 hours, the grid connection was deliberately disengaged under controlled conditions. The automatic transfer switches activated, and the diesel generators assumed load. Initial readings indicated stable operation. At 0810 hours, as the generators continued under near maximum load, a rise in exhaust temperature was recorded on generator 2. Operators adjusted fuel input in accordance with standard procedures. The temperature stabilized, and the test continued. At 0845 hours, the engineer authorized the gradual reintroduction of selected non-essential loads to assess generator performance under increased demand. Load was increased incrementally, and readings were recorded at each stage. By 0915 hours, the generators were supporting a load approaching their rated capacity. At 0930 hours, a sudden loss of lubrication pressure was recorded on generator 1. Automatic safety systems initiated a shutdown of the affected unit. The remaining generators continued to supply power, but load redistribution resulted in increased strain. Operators initiated standard emergency procedures, including load shedding to maintain stability. The engineer directed immediate inspection of the shutdown generator. Maintenance personnel reported damage to a lubrication line and contamination of the oil system. The incident was logged, and the generator was declared temporarily out of service. At 1005 hours, with only 2 generators available, the engineer authorized reconnection to the regional grid. The transfer was executed, and normal power supply was restored. Production systems resumed full operation, with minor delays recorded in affected areas. Following the test, an incident report was compiled. The report detailed the sequence of events, equipment readings, and corrective actions. The engineer appended a recommendation to conduct further inspection of lubrication systems across all generators and to expedite procurement of replacement parts for the damaged unit. On August 13, 1942, inspection of generator 1 revealed extensive internal wear inconsistent with recent maintenance records. The findings were documented, and the generator remained offline pending repairs. Temporary reliance on grid power and the remaining generators was deemed acceptable under current conditions. On August 15, 1942, the engineer submitted a comprehensive report to the Reich Ministry of Armament summarizing the emergency power test, the generator failure, and recommended corrective measures. The report was acknowledged by the ministry, and authorization was granted to prioritize repairs. Between the 16th and the 22nd of August 1942, maintenance crews worked on generator 1, replacing damaged components and flushing lubrication systems. The engineer supervised critical stages of the repair and signed off on completion on August 22. A post-repair test indicated restored functionality. On August 25, 1942, an unannounced security inspection was conducted by regional security police representatives. The inspection included review of access logs, credential verification, and examination of sensitive infrastructure areas. The engineer's documentation and credentials were reviewed and accepted as valid. No security breaches were reported. In early September 1942, the plant continued to operate under elevated production demands. Power system performance remained stable, and emergency generators were returned to standby status. The engineer maintained his routine presence and reporting schedule. On September 9, 1942, at 0315 hours, a significant pressure surge occurred in Boiler 2. Automatic safety systems activated, venting steam and reducing fuel input. The surge resulted in damage to internal boiler components and a temporary loss of steam supply to one turbine. The turbine shut down automatically, and load was transferred to the remaining turbine and grid supply. Production was partially interrupted. Emergency maintenance crews were mobilized, and the engineer was notified. He arrived on site at 0410 hours and coordinated assessment of the damage. Preliminary findings indicated failure of a pressure regulation component and structural stress within the boiler. At 0600 hours, the plant director authorized a controlled shutdown of the affected boiler for repairs. The decision was documented in an administrative order. Production schedules were adjusted, and priority was given to critical components. Throughout the 9th and the 10th of September, repair work proceeded. The engineer oversaw pressure testing and replacement of damaged parts. By the evening of September 10, the boiler was returned to service at reduced capacity, pending further inspection. On September 11, 1942, the engineer submitted a detailed analysis of the boiler incident, including recommendations for modifications to pressure control settings and monitoring protocols. The analysis was forwarded to the ministry. On September 14, 1942, at 2240 hours, a fire broke out in the turbine annex. Initial reports indicate ignition within the cable routing area adjacent to the central switchgear. Fire suppression systems activated, including CO2 discharge in enclosed sections. Power to the affected area was cut automatically. Emergency response teams contained the fire within approximately 20 minutes. Damage assessments conducted overnight revealed extensive damage to cabling, control panels, and insulation. One turbine sustained heat-related damage and was declared inoperable pending major repairs. Production was halted across the facility due to loss of power distribution capability. The plant director issued an immediate shutdown order at 2315 hours, documented in the administrative log. On September 15, 1942, investigators from the Armaments Inspectorate and Security Police arrived to assess the incident. Access to the facility was restricted, and all personnel movements were logged. Preliminary findings attributed the fire to an electrical fault exacerbated by high load conditions. The engineer was interviewed and provided technical documentation and inspection records. On September 18, 1942, an administrative decision was issued by the Reich Ministry of Armaments to suspend operations at work number 417 pending comprehensive repairs and review. The decision cited damage to critical infrastructure and the need for reassessment of safety protocols. The suspension order was entered into the official register. Subsequent records indicate that the engineer's assignment was terminated effective September 20, 1942. His access credentials were deactivated, and his departure from the facility was logged. No further entries document his activities thereafter. Archival files conclude with a notation dated September 30, 1942 indicating that repair estimates exceeded projected timelines and that production capacity at the facility would remain offline indefinitely. No additional operational records for work number 417 are present beyond this date.